Every year, there are over 1 million wildlife vehicle collisions in the U.S. alone. These collisions cause 29,000 human injuries and over $1 billion in property damage annually. Chances of being struck and killed as a pedestrian increase 1,100% after dark. 8 out of 10 drivers who struck people at night didn't see them. Pedestrians and bicyclists are at considerable risk of being hit by a vehicle when the weather or lighting conditions are subject to poor visibility. Simply entering car accidents at night will produce a Google search of over 15 million hits. These staggering statistics are the reason why we are designing an early warning system that can be installed on any vehicle, including motorcycles. If an unseen animal or person could be detected in low visibility conditions, this would effectively give a driver more time to react and would result in far fewer collisions. Our product is designed for any driver who wishes to increase their safety factor while driving at night or in inclement weather. For automobile manufacturers who wish to add a safety feature to their vehicles, an attractive selling point. For trucking companies who know the long haul has a high probability of incident. And for commercial retail stores that could turn an easy profit on promising, innovative new technology. This is our prototype. We use a basic PIR, or passive infrared motion detector, combined with an LCD screen and LED. When motion is sensed, the LED lights up and the LCD displays a message. When the motion ceases, the LED turns off and the LCD displays a motion stopped message. This is a very simple prototype that demonstrates the type of technology we're using for our product. Our final design omits the LCD screen in favor of an LED-only interface. This cuts down on cost and prevents distraction. A PIR sensor has 2 slots that see an area. When infrared energy is seen in one slot and not the other, it causes an electrical imbalance. This imbalance is what triggers the sensor to output a signal. This signal can be used to turn on an LED and tells the viewer that something has been detected. The real challenge is not in proving this technology works, but in transforming a stationary detector into a system that can be mounted on a moving vehicle. The first consideration is background fluctuation. As the sensor is moving, fluctuations in background temperatures could produce false positives. The use of a differential amplifier can solve this problem. A differential amplifier receives signals from both halves of the sensor. This allows the average temperature of the field of view to be removed from the electrical signal. An increase of IR energy across the entire sensor is self-canceling and will not trigger the device. This includes oncoming headlights, wind, and broad thermal discrepancies. The next challenge is range. Focal length, width, and height can all be manipulated with a Fresnel lens. With the proper lens, we can make a sensor see as far as 1,000 feet. With range and background accounted for, we also want to have 3 detection areas: left, right, and center. By using a 2-dimensional array analyzed by a microcontroller, we can effectively have 3 areas. This also allows for detection of movement. For instance, if the object sensed started moving toward our path, the 2D array could determine it. Lastly, a filter can be used to further diminish noise and false positives. Humans and animals emit IR between 7 and 14 micrometers. Using a filter omits readings outside this range and results in a much more accurate system. Currently, there is not a commercially available product like ours on the market. However, there are high-end automobile manufacturers that offer add-on packages for $2,000 to $2,500. The first uses near-infrared technology. Also known as an active system, it uses a pulse light source and synchronized camera to produce images on a screen. Unfortunately, these systems can only see about 500 feet and do not work well in fog and rain. The second system uses a thermographic camera to capture infrared energy and is known as a passive system. It can see to 1,000 feet but produces grainy visuals and performs poorly in warmer weather due to the nature of the camera. Our product would not use a camera, nor would it use a screen. We feel taking your eyes off the road to look at a screen is counterproductive to preventing a collision. Our system uses LED lights on the instrument panel to alert the driver through peripheral vision. The lights would be placed left, right, and center. If an object was sensed from the left LED would illuminate. If an object was moving toward the driver's path, the LED would start blinking to signal increased danger. Once the object had been passed, the light would turn off. This is a protocol for all 3 LEDs. Our design would have an effective range of 1,000 feet, would work well in rain, fog, and warm weather, would never require the driver to take their eyes off the road, and would only cost $500. Perhaps the best feature is that it would be available commercially and could be installed in any vehicle, new or old. Our market analysis requires some creative license. There is only one type of product on the market related to ours. That is the deer whistle. Over 2 million have been sold to date. This suggests that there are a large number of drivers who wish to avoid deer. However, we needed to establish more concrete evidence of a need. We found overwhelming statistical data to support the need of our device. For example, the average headlight illuminates 150 feet of roadway. Traveling at 55 miles an hour, it takes 260 feet to stop. Our device sees 1,000 feet, thus giving the driver ample time to react. We also conducted a random poll of 42 people and found on average 60% would purchase our product. Considering all the data we collected, we determined our idea does solve a problem people care about and is therefore market-worthy. We then conducted the Josh Kaufman quick test, answering each question as honestly and accurately as we could. At the end, we scored 71. Still in the yellow area, but close enough to 75, we decided it was worthy to move on. Finally, we considered what our design offers to the consumer. We deemed it novel and useful, something new and innovative that would spark interest. It provides protection from injury and property damage and lends peace of mind while driving at night and in dangerous weather conditions. When considering the launch of a new product, it's important to estimate cost and profitability. Our numbers are best guess conservative estimates. Since no product like ours exists, approximating cost is a dubious venture. That being said, we estimated 2,500 units could be sold in the first year. Looking at current technology, we estimated a working cost of $250 per unit. We then sell each unit for $500, resulting in a revenue of $1,250,000 for the first year. After approximating production costs, we arrived at a gross margin of $475,000. This in turn gave us a net income of $137,625 with a net profit margin of 11.01%. However, as stated before, these are only estimates made with our existing knowledge, but this does suggest a high potential for success in the marketplace. At the end of any project, it's always good practice to look back on one's process and reflect on what was learned and what insights were gained. We learned 3 important concepts over the course of this project. The first is to keep the customer as the focus of your product. This ensures a greater chance of success with a product that meets the needs of the consumer. The second is to make sure your product has a market. Just because an idea might be cool doesn't mean that it is marketable. A person can save themselves time and grief if they do market research before they ever engage a prototype. The third is to keep the product simple. Bells and whistles don't sell, they only augment. Therefore, keep the product simple and useful, with a focus on being useful. This ensures a marketable product. Throughout the course of this project, we found as a team that we are great at sharing the workload, communicating, and being efficient. These qualities really help us to perform at our best and achieve great results. However, we are slow to generate ideas, which more practice and critical thinking will help us to overcome. We're not always on task. Limiting distractions and decreasing procrastination will serve us well in the future. At times, we lack the ability to convey our ideas clearly. Practicing communication is a solution to this obstacle. In the end, we realized how truly important communication and dividing the workload is in a collaborative process. Many hands make the work easy, and strong communication eradicates stalls and ambiguity. 2 ideas that can serve all to further excel in their endeavors. Thanks for watching.